all. So this is Sulak Kumar from SNS College of Technology. So now I'm going to tell about CPU scheduling algorithm, which is consist of multiple process scheduling in operating system. So first of all, multiple process scheduling means if multiple CPUs are available, so load sharing becomes possible. But the scheduling problems become correspondingly more complex. So these approaches are two multiple processing. So one is asymmetric multiprocessing, second one is symmetric multiprocessing (SMP). So a multiprocessor system has all scheduling decisions and input output processing and the other system activities, and also it is handled by a single processor. So the master server, the other processor execute only user code. So this asymmetric multiprocessing is simple because only one processor access the system data structures and reducing the need for data sharing. So second one, symmetric multiprocessing (SMP). So where each processor is self-scheduling. So all processors may be in a common ready queue, or each processor may have its own private queue of ready process. So regardless, scheduling proceeds by having the scheduler for each processor and examine the ready queue and select a process to execute. And if we have multiple processes trying to access and update a common data structure, the scheduler must be programmed carefully. So we must ensure that two separate processors do not choose to schedule the same process, so and that process are not lost from the queue. Next one, processor affinity. If the process migrates to another processor, so the content of cache memory must be invalidated for the first processor, and the cache for the second processor must be repopulated. So because of the high cost of invalidating and repopulating cases, so most SMP systems try to avoid migration of process from one processor to another, and instead of attempt to keep process running on the same processor. So this is known as a processor affinity. So that is a process has an affinity for the processor on which it is currently running. So soft and hard affinity. So when an operating system has a policy of attempting to keep a process running on the same processor, but not guaranteeing that is will do so, we have a situation known as soft affinity. So here the operating system will attempt to keep a process on a single processor, but it is possible for process to migrate between processes. So in contrast, some systems provide system calls that support hard affinity, so thereby allowing a process to specify a subset of a processor on which it may run. So the main memory architecture of system can affect processor affinity issues. So when we have a NUMA and a CPU scheduling, so we have two different CPU scheduling. CPU is available for a fast access and a memory and a slow access. So one CPU can request to another CPU, it will make us a slow process access, and it is CPU can access the same memory in the CPU is a fast access. Load balancing. So load balancing attempts to keep the workload evenly distributed across all processor in an SMP system. So otherwise one or more processor may sit idle while other processor have high workloads. So along with list of processors awaiting the CPU. So there are two general approaches to load balancing. So push migration and pull migration. So with the push migration, a specific task periodically checks the load on each processor, and if it finds an imbalance, evenly distribute the load by moving or pushing process from overloaded to ideal or less busy processor. Pull migration occurs when an ideal processor pulls a waiting task from a busy processor. Push and pull migration need not be mutually exclusive and are in fact often implemented in a parallel on load balancing systems. Interestingly, the load balancing often counteracts the benefits of processor affinity. Multi-core processor. So multi-core processor scores based on the same physical chip, resulting in a multi-core processor. So memory stall. So when a processor accesses memory, it spends a significant amount of time waiting for the data to become available. So the situation known as a memory stall may occur for various reasons such as a cache miss and data that are not in a cache memory. So to remedy in the situation, many recent hardware design have assigned to each mode. That way, if one thread is stalls while waiting for memory, the core can switch to another threads. So there are two-way multi-threader processing around a coarse grained and a fine grained multi-threading. So do two different levels of scheduling. So one allow scheduling decisions that must be made by the operating system as it chooses which software threads to run on each hardware thread logic processor. A second level of scheduling specifies how much each reset which hardware thread to run. So that's all about the multiprocessor scheduling. Thank you.